Okay, imagine this. A computer that doesn't just, run your apps, but actually senses the planet warming up around it
Right.
and responds. Sounds a bit sci-fi, doesn't it?
It does a little bit.
But what if that idea, that sci-fi future, is actually taking shape right now? Like as a foundational operating system.
Yeah, that's the core concept we're exploring.
So today, we're doing a deep dive into something called warming OS. It's this idea that bridges our digital world with the very real shifts in our climate.
Exactly.
The goal here is to unpack what warming OS really means, explore these different interpretations we found, and sort of understand how it could be a base layer for climate-aware digital stuff. We got this really fascinating report guiding us.
That's right. And it's really important to get this up front. Warming OS isn't like one single product you can just download.
Okay, not an app.
No, not an app. Think of it more as a conceptual framework. Basically, an operating system or maybe an embedded platform that's specifically designed to, well, detect, adapt to, or even actively manage environments that are going through big thermal changes, climate changes.
Okay, so it's a framework.
Yeah.
Yeah.
And the applications are incredibly broad. It could really impact fields from, say, smart agriculture, critical infrastructure up in the Arctic,
Wow.
even how we manage our data centers. It's fundamentally about building a digital foundation that actually understands the physical world it operates in.
Right, understands and reacts. Okay, let's unpack that then. The report, it breaks warming OS down into three pretty fascinating interpretations.
It does.
Each one seems to tackle a different layer of this climate-aware intelligence idea. Where should we start? Let's do the first one.
Okay, yeah. The first interpretation is what the report calls a climate monitoring OS.
Climate monitoring OS. Got it.
So this version, it acts essentially as a really sophisticated platform. Think of it managing these vast networks of environmental sensors.
Okay, like connecting all the dots.
Exactly. Its main job. Detecting those really subtle temperature rise patterns, maybe automating certain climate response mechanisms, and definitely coordinating with critical early warning systems.
So like flood warnings or drought predictions.
Potentially, yeah. Key features would be things like real-time climate telemetry integration. So pulling in just massive streams of data.
Yeah.
Think about combining satellite data with very precise on-the-ground sensors, using predictive analytics to spot anomalies,
Okay.
and offering open APIs so it can easily plug into other critical systems like disaster management platforms or, agricultural tech.
Right, so other systems can use its insights.
Precisely. And for real-world use cases, imagine hyperlocal monitoring in the polar regions, in the Arctic.
Which were changing so fast.
Exactly. Or early warnings for desertification, for drought, maybe incredibly detailed urban heat island detection for smart cities.
Oh, that's a big one.
Huge. And even predicting glacier melt for, crucial hydrological forecasting, water resources.
Okay, that makes sense. But it does raise a big question for me. How precise can that level of monitoring actually get?
That's a critical question.
And how quickly can you scale something like that up? Is it data accuracy there yet? Or is that like one of the big hurdles for this climate monitoring OS?
Well, precision and scalability are definitely ongoing challenges. There's no doubt about that. But the goal is constant refinement.
Okay.
I mean, think about the impact of just slight temperature changes over long periods.
Right.
Every fraction of a degree matters in these climate contexts.
Right, absolutely.
Which actually leads us nicely into the second interpretation,
Okay.
the thermal-aware edge OS.
Thermal-aware edge OS. Okay,
Mhm.
so edge meaning out there on the devices themselves.
Exactly. If the first OS is about seeing the whole warming planet, this one is more about making our technology feel it,
Yeah.
and adapt directly. Almost like a living thing reacting.
Huh. Interesting analogy.
Yeah, it's really about making individual devices smarter and, crucially, more resilient, especially when they're operating out in harsh conditions. High temperatures, volatile climates.
Like drones flying in the desert or sensors on a pipeline.
Perfect examples. The core concept here is that these devices at the edge, drones, IoT units, industrial machines, they dynamically manage their own heat.
Ah, okay.
A bit like how your laptop might use thermal throttling, right? It slows down to avoid overheating.
Yeah, mine does that all the time.
Well, this OS would do that, but for critical infrastructure components, optimizing its resources on the fly based on the thermal conditions.
So it's like giving every piece of important tech its own tiny built-in meteorologist.
Yeah, sort of.
Except this meteorologist actually gets to, like, turn down the heat or decide if the cooling needs to kick in harder.
Exactly. That's a great way to put it. Its core components would include drivers that read thermal telemetry from the CPU, the GPU, the memory, and energy-aware task scheduling. So it prioritizes what needs to run based on heat and power. Real-time thermal maps of the device itself,
Oh.
and even predictive shutdown triggers to prevent catastrophic damage. It would also orchestrate any integrated cooling hardware, like fans or heat sinks.
Okay, that sounds incredibly sophisticated for an individual device.
It is, and the practical applications are pretty compelling. Think autonomous vehicles that have to endure extreme desert heat,
Right.
or those off-grid remote sensing units deployed in the hottest places on Earth. Equipment at mining sites, geothermal sites.
High-stress environments.
Definitely. And even data centers, maybe one specifically built or located in climate-challenged zones where cooling is a major issue.
Okay, what's really fascinating there, I think, is how it brings that intelligence right down to the source, right where the heat stress is actually happening.
That's the key. Direct, localized adaptation.
Okay, so that thermal-aware Edge OS, that sounds like a game changer for individual devices, their immediate surroundings. But I'm thinking bigger picture now. Places like, I don't know, vulnerable coastal towns or those isolated Arctic communities you mentioned.
Right.
How does this warming OS idea scale up to protect entire infrastructures in those kinds of extreme environments? And what's the biggest hurdle in making that happen?
That's a perfect transition to the third interpretation, the adaptive OS for extreme environments.
Okay, adaptive OS.
Yeah, this one's a bit more generalized. It's an operating system specifically tailored for, say, infrastructure and computing in geographies that are really facing significant warming impacts.
Like those Arctic towns or coastal areas.
Exactly, or maybe island nations, desert communities. Its capabilities would go further. It might include self-healing software modules that respond directly to external climate data inputs.
Self-healing, how does that work?
Well, it might automatically reroute processes or shift workloads or activate backup systems based on predicted or real-time climate stress, like an impending storm surge or extreme heat wave warning.
Ah, okay, proactive defense.
Exactly. Using edge-native protocols for really low latency adaptation so it reacts fast. It could even dynamically change computing workloads based on, say, seasonal viability. Maybe certain heavy processing only runs in cooler months or immediate climate risk.
That's smart. Resource management based on climate.
Yeah, and crucially, it allows for remote over-the-air updates, OTA updates, even over satellite links, which is vital for systems in really isolated locations.
Right, you can't exactly send a technician out easily.
Not easily, no. So who would use this? Strategic users would likely be governments, municipalities trying to manage climate risks, energy companies.
Especially offshore or Arctic ones.
Definitely. Offshore, Arctic, desert operations, climate tech startups, of course, and NGOs working on the ground in vulnerable regions. If you connect this to the bigger picture, this is really about building resilience from the ground up, making entire systems adapt proactively to their changing world rather than just, reacting after the damage is done.
It really does sound incredibly powerful, almost like building these, I don't know, digital organisms that can actually survive and function through climate change.
That's a compelling way to think about it.
So what are the really big benefits we're looking at? What makes a system like this potentially so revolutionary?
Well, the benefits are pretty significant, I think. First, you've got that real-time thermal adaptation we talked about with the Edge OS.
Right.
That's not just about preventing hardware failure, though that's huge. It directly translates to preventing significant energy loss, too.
Ah, the efficiency angle again.
Exactly. Keeping systems in their optimal temperature ranges reduces their own digital footprint. Then there's climate-aware automation. This isn't just reacting. It enables genuinely proactive decisions in critical sectors. Think agriculture, disaster response, energy management. It lets us actually get ahead of problems.
Moving beyond just responding after the fact.
Precisely. It also ensures resilient edge deployment. This means systems can operate reliably even in really unpredictable warming environments where, frankly, traditional tech might just fail.
Yeah, you can see that happening.
And finally, a key design goal is making it integration friendly.
Meaning it plays well with others.
Exactly. It needs to work seamlessly with existing systems. Things like satellites, GIS,
Geographic information
that
systems, right? Mapping data.
right, for spatial data mapping,
Yeah.
or integrating with diverse communication networks like 5G for speed, or maybe LoRaWAN for low-power, long-range IoT devices out in remote areas.
Okay, so it fits into the existing tech landscape.
That's the idea, yes.
It does sound almost like a silver bullet, which, always makes me a little skeptical.
Rightfully so.
Nothing in tech is ever that simple. What are some of the immediate hurdles, the big challenges that stand in the way of a warming OS really taking off beyond just, building the code?
Yeah, you're absolutely right to be skeptical. No silver bullets here. There are significant challenges. First off, data security.
Always a big one.
Huge here. Climate and environmental data can be incredibly sensitive. Think critical infrastructure status, resource availability. It needs robust protection from bad actors, and you have to ensure the data integrity is solid.
Can't have someone spoofing temperature data.
Absolutely not. Then there's hardware variability. We touched on this. For this to work effectively, the OS needs to be compatible with just a vast array of sensors, devices, controllers across different industries, different ages of equipment.
That sounds like a massive engineering headache.
It is a significant feat in itself.
Yeah.
Then practicalities, power and bandwidth limitations.
Especially out at the edge.
Exactly. In remote areas, grid-isolated regions, providing consistent, reliable power and enough connectivity for data transfer. That can be incredibly difficult and expensive.
Yeah, a major constraint.
And finally, something inherent to the problem, climate unpredictability. The system has to be able to integrate and make sense of probabilistic forecasting. Climate models give ranges, likelihoods,
Not certainties.
not certainties, so the OS needs to function with that uncertainty, which raises that really important question. How do you actually build systems that can learn from and adapt to constant, unpredictable change, not just react based on fixed rules?
That's kind of the million-dollar question for the engineers, isn't it?
It really is. It's at the core of what makes this so challenging, but also, frankly, so exciting.
Absolutely. If we can build systems that learn and adapt like that,
Yeah.
okay, who needs to be involved? Who are the key players that would actually bring something like warming OS to life?
You'd need a lot of collaboration.
I bet. And what kind of impact could it have on, say, entire industries?
Well, for collaborators, you're looking at major agencies, obviously. NASA, NOAA, the European Space Agency, ESA. They provide crucial satellite data, climate models, research.
So big science organizations.
Definitely. Alongside them, polar research agencies, renewable energy companies are key stakeholders. Smart agriculture platforms. The report even mentions specific examples like John Deere or CropX as potential partners.
Interesting. Big ag getting involved.
Yeah, and the industry disruption. It could be truly transformative. Think about how it could revolutionize smart infrastructure systems, cities, grids, transport.
Making them actively climate adaptive.
Yes. It could also enable totally new forms of climate fintech, like parametric insurance.
Parametric.
What's that exactly?
So it's insurance that pays out automatically based on specific, predefined climate triggers being met. Say, wind speed hitting Category 3, or river level reaching a certain height, or temperature exceeding a threshold for X days.
Oh, okay. No lengthy claims process. Exactly. And what's really revolutionary here isn't just a faster payout. It's how a warming OS could potentially eliminate the subjective claim process almost entirely.
Oh, so?
By providing trusted, real-time, irrefutable climate data, feeds directly into the insurance contract. The payout becomes automatic based on objective data. It shifts risk management from reactive assessment after an event
to proactive, data-driven resilience before and during it.
Wow, precisely. It's a paradigm shift. And it would also significantly boost supply chain resilience platforms, making them truly climate aware, not just weather aware.
That's a really profound shift in thinking. Okay, let's look into the crystal ball a bit. If all these pieces start falling into place, what are some of the really cutting-edge directions this whole concept might take in the future?
Oh, the future directions are incredibly exciting. They really push the boundaries. Imagine, for instance, an AI-native climate OS.
AI native, meaning AI is core to it.
Yes, where large language models, like the ones we hear so much about, could interpret complex environmental data and present it in natural language.
Making it accessible to non-experts.
Exactly. Accessible and actionable for everyone, from scientists to city planners to local community leaders. We can also see a push towards an open-source warming OS.
Like Linux, but for climate adaptation.
Kind of, yeah. A global, collaborative effort. Sharing sensor data standards, system developments, code, accelerating innovation through openness.
That could be powerful.
Very. Then integration with things like tokenized climate credits.
Okay, connecting it to carbon markets and finance.
Precisely. Directly linking measured environmental impact or positive actions detected by the OS to economic incentives, creating new verifiable market mechanisms.
Interesting. And you mentioned resilience.
Right. The idea of decentralized resilience networks, leveraging technologies like blockchain or distributed ledger technology, DLT.
For more security and trust.
Exactly. To create even more robust, transparent, tamper-proof, and secure systems for managing critical climate data and responses, especially across different organizations or borders.
Okay, so the future could involve AI, open source, crypto economics, decentralization. Lots of buzzwords, but applied to a really critical problem.
They are buzzwords, but here they represent potentially powerful tools. What's truly fascinating, I think, is that warming OS represents this powerful convergence.
Yeah.
You've got climate resilience meeting embedded systems, meeting advanced edge AI.
Yeah.
It's not just another technological upgrade. It's really about building a fundamentally more responsive, adaptive, and intelligent layer for our entire digital infrastructure in a world that is undeniably rapidly changing.
It really paints a picture, whether it's about, safeguarding those delicate ecosystems up in the Arctic or providing those crucial early warnings for drought-prone deserts, or maybe just optimizing energy use in our sweltering urban heat islands.
Yeah, all of that.
But this whole idea of a warming OS, it really does suggest a future where our technology is intrinsically linked to the health of our planet, actively responding to it.
That's the core vision.
So for you, the listener, here's maybe the provocative thought to leave you with. As our planet continues to warm, will our digital systems evolve to become maybe our most vital allies? Not just helping us adapt to the changes that are coming,
Right.
but actually shaping our ability to build a more resilient future and maybe even thrive within it.